So that's why we propose the 3 cluster solution.
Okay.
So this is the intuitive way to understand what is the 3 cluster.
Yes.
If you think a car with 2 gears, then in the light loading or heavy loading, you can maybe switch gears to handle this kind of task. But in the middle, probably it cannot do this very well. But if we have extra gear, for example, if we have 3 gears, then we can handle this case also very well. So that's easy to understand. For this one, this side is the little bit complicated. So this is the performance, this is power. So the green line is the little core, red one is the big core. So you can think tri-cluster, we add the third one, mid, and we lower the minimum one with less power, and with big one is more performance.
Yes.
So compare with the only 2-gear solution, big and little, you can see here the yellow area. This is the benefit we have. For example, if you think of this is
so what would this mid-performance band? What would be an example of the mid-performance band computing? What would a customer be doing?
Customer
to take advantage of this area.
We will do it in our reference software, so customer can have this kind of benefit automatically.
But what would be an example of a set of computing tasks that the customer would be doing that would fit into the mid-band?
Okay. This one is example application. For example, this one is light loading, and this one is more heavier loading. But mid one probably kind of this, for example, Facebook or some game, some video program.
Okay.
And
wow, that's quite a bit of power improvement.
Yeah, we measure some typical or some usage on the mobile phone. And this one is the only big little architecture. And this one is the 3 cluster architecture, and their power consumption under this kind.
So wow, web page loading is your maximum.
Sorry.
Web page loading is your maximum of 0.6 watts.
Okay. In these scenarios is this, yes. But
your big loading is like Facebook stuff.
Yeah.
So Facebook's is largely static, but it has some video content. But the video content it has is very small.
Yeah.
Yeah. Okay.
So this is advantage or improvement over the only 2 cluster architecture.
Gotcha.
So overall, you can think with 3 cluster, we can have 30% power savings.
Okay.
So that's the advantage of 3 clusters.
Okay.
So this slide shows the Helio X20 first 3 cluster benefits of architecture. So any comment or question?
So I'm not. So I thought that I'm still relatively new in this business. I've only been at it for a year, and I've had lots of other things to do, but to help get a business started.
Okay.
But and I'm a mechanical engineer by training, so I'm trying to keep my head above water. So it looks to me as though to go from an 8-core microprocessor to an octa-core microprocessor, the performance gain is actually not very high. Is that true?
Okay.
In percentage terms. So you're not going to be 2x percentage.
Okay. It is not linear. Non-linear because there are some overheads between the
to manage the
processor cores.
Okay.
For example, they need to synchronization, they need to share.
Right.
So
it's like an organization. The more people there are, the less efficient the organization becomes.
Like this, yes. So it is not linear, yes.
Okay. Okay, so by non-linear, the overall improvement in speed for an 8-core versus a quad-core MPU would be 20 or 30%.
Okay, you mean average improvement?
Yeah, on average. Yeah. So this is the power gain.
This is power gain.
Yeah,
yes.
but there's in terms of the speed gain or performance gain, especially the customer would see for like web page loading.
Okay.
Because I do see that.
Okay.
I mean that seems to be your highest.
Okay, this one shows the power gain, right?
Yeah.
If you think the performance-wise, it also has the benefit. For example, we have 3 gears, right? So actually the task, when it needs more CPU performance, it will be migrate to max CPU core.
Right.
So in terms of performance, it also has the benefit.
Okay. But it's using fewer cores on the low intensity tasks, yes?
You mean for...
So just for my home screen, for example, very light task.
Yes, for a home screen idle, it only use one
core.
Very little core. So
yeah,
you can see.
Are all the cores the same size? Are they all duplicates of each other, or are they different? Are they different sizes?
3 cluster has 3 different type processor core. So they are different in size.
So they're really different from each other.
Yes. 3 types of processor.
Okay. So when I take a look at this looks like, that's like 90-something%. And this looks like it's maybe 110 or something. So I'm looking at like a 25% increase.
This is
if that's
just
more
for,
than representational.
Yeah, this is for presentational, not the absolute value.
Okay.
It means we try to increase the maximum performance, right? So if you compare with the old one, like here, we set it to 100, right? Then we can extend more. That's just for presentation.
For presentation.
Yeah. Not
That's an
the
artist's
real value.
view. Okay. Okay. So what would the real value be in terms of performance for intensive applications for like web page loading? Because I've noticed, for example, because I use my own products, when I'm loading even a relatively low intensity website, but does have some graphics and does have some embedded video sometimes. Sometimes it will take actually quite a while to load, even when I have a good Wi-Fi signal and I know there's not a lot of other traffic on that Wi-Fi. So it seems as though, that fits well with this graph here.
Yes.
Saying that web page loading is actually pretty intensive.
Yes. So we have a really powerful big CPU.
Okay.
Yeah.
So what would be the increase in performance for, say, the Helio X20 over, say, I want to say the 8753? I'm not sure about the number.
Yeah, it's 72. Cortex A, 72.
Yeah. So what would be the average performance increase for web page loading between those two MPUs?
You mean compare with this one and which one? X10 or X?
Yeah.
Okay. I don't have the exact number here.
Yeah, no. Ballpark numbers.
Okay. But I think for average, you can expect maybe over 30%.
Over 30%
improvement. Yeah.
So noticeable. Because what I found is if it's not a 30% difference, I think my brain, maybe your brain is different, or maybe your brain is different. My brain, if it's not a 30% difference, it's almost like it's linear.
You cannot notice, right?
It's almost linear in decibels. So if it's 10 times faster, you go, wow, that's a lot faster. But if somebody says, is it 10 times faster? You might go, no, maybe twice as fast. Right? I mean, that's just a perception.
Okay.
But 30%,
maybe
I'll notice for 30%. Not tremendously, but I'll notice.
Okay. But okay, that's my estimation. we need to do some performance fighting or some system optimization.
Okay. Okay. And then the Helio X20 that's compatible with what 5.2 is the latest Android OS?
Okay, we will hold the latest Android software stack on it.
Okay.
Probably current version is 5 point something.
Yeah.
The Android L.
Right. So now, let me ask another question. What I've noticed is that the people who are doing our supplying are pretty far behind the power curve in terms of, especially the leaders, like Samsung, for example. So, is that because as soon as your latest chipset comes out, Samsung comes along and says, "I'll take everything you can send me," and you say, "Okay," and so it all goes to Samsung, and then the smaller second tier providers get left in the cold, shivering in the cold for maybe 6 months or so. Is that an accurate understanding of what
Sorry,
things happen?
I cannot comment on Samsung because
I'm sorry, I threw that out there as just a generic manufacturer. So your early manufacturing, is that spoken for typically by tier 1 cell phone manufacturers? And kind of the tier 2 cell phone manufacturers have to wait quite a while to get access to the chips?
Because I am
You're not in marketing.
I'm not marketing, so I don't know how to answer this.
Okay.
I can connect you with our marketing guy.
Yeah. Okay.
Sorry. Yeah.
I'm just looking to understand. So.
Yeah.
Because I've just noticed that difference. I'm like, why would that be true if they got the same access at the same time? And if I were you guys, I would do it that way. So I can't really blame you if you are. But I'm also thinking that there is another option, another possibility, and the other possibility is only the tier 1 people have the engineering teams to quickly understand the MPU, and so of course they're going to be faster to market because their engineering teams are better than the tier 2 engineering teams. So I'm wondering if maybe that's an alternative explanation. And I'm kind of wondering, like, what is the power of those two?
That sounds reasonable to me.
Yeah.
Yeah.
Well, they both sound reasonable because it's what I would do on the first case, and it would be understandable in the second.
Yeah.
But in the second case, I can tell them to get better engineers. In the first case, there's nothing good to be done.
You are right.
So, okay. Well, good to meet you, and thank you.
Thank you.
Wow.